Hello, I'm the multifaceted Mr. Daycock, and today I'm going to be teaching you how to solve quadratic inequalities. So what is a quadratic inequality? An example of a quadratic inequality is right here. And first of all, we need to take apart what this means. What does it mean to say x squared plus 7x plus 10 is less than or equal to 0? The question it's asking is, for what values of x is our actual function we care about, which we might call f of x, less than, or in this case, because of course our extra line, or equal. But this is the key thing. The question is, what values of x? The question, that's what we're looking for. Just like solving an equation, we're looking for the values of x, not the values of this. So what values of x make that true? Now over here, I've got a table of all the different values. So if I put in x equals negative 10, the equation gives out 40. Our formula, our f of x, gives out 40. If I put in x equals negative 9, I get 28, and so on and so forth. And as a quick reminder of how to do that, let's do negative 3 ourselves. So we have x squared, our f of x is equal to x squared plus 7x plus 10. So our f of negative 3, putting in negative 3 in place of x, is going to be equal to negative 3 squared, using brackets to make sure we remember we're squaring the whole thing, plus 7 lots of negative 3 plus 10. And we can just work that out. Negative 3 squared is positive 9. 7 times negative 3 is negative 21. And then we're adding on 10. Working on that, we get negative 2. And so we can fill in this one here for negative 2. And now looking at this, we can probably answer the question, what values of x is this quadratic less than 0? Well, it's these ones here. For it to be less than or equal to 0, negative 5 gives us 0, negative 4 gives us negative 2, negative 3 gives us negative 2, and negative 2 gives us 0. So we might just be able to say x equals negative 5, negative 4, negative 3, and negative 2. And although that is some of the solutions, it isn't all of the solutions. We need to go a little bit further, and we need to work out other possible solutions to this question. Because what about, let's say, negative 5.1? Or what about negative 3.2? Or negative 1.9? Or negative 2.1? Which of these also give us less than or equal to 0? Because every number in between negative 5 and negative 4, the infinitely many numbers between negative 5 and negative 4, how do we know about them? Well, the trick in that regard is to think about our quadratic graph. And we know, if we think about a graph, we know on our graph that at negative 5 we get 0, and at negative 2 we get 0. And so, and we also know it goes a little bit below, between here and here, at negative 3 and negative 4, and it looks like our graph is going to look like this. And we know the shape of a quadratic graph. A quadratic graph always looks like this. So what that tells us is it is all the area between negative 5 and negative 2 that gives us values less than 0. Things that give us less than 0. If I pick a value of x, because this is my x-axis, and this is actually sort of my f of x axis, if I pick a value bigger than negative 2, then it doesn't work. If I pick a value less than negative 5, it doesn't work. Those will give me values bigger than 0. So I just need these ones in here. These are the ones that drop below the axis, where if I put in an x value here, pick an x value, it gives me a value below 0. And so the answer to our inequality here is our x has to be less than or equal to negative 2 and less than or equal to negative 5. Okay. And that's the principle at work. We've identified where it has to be. Now, these here are called our critical values. The point where f of x equals 0, the values of x where f of x equals 0 are our critical values. Because if it equals 0, that's where we change from being less than 0 to being more than 0. So let's look at the next question in terms of that. Solve the inequality x squared minus 3x minus 18 is greater than 0. So what we want is our critical values. And those happen when our f of x is 0, or in this case where x squared minus 3x minus 18 is 0. And so this is what we have to solve. To get our equation, we have to get our critical values, we have to solve the equation, not the inequality. Okay, so how do we do that? Let's factorize. We get two numbers that multiply to negative 18 but add to negative 3. We get x minus 6, x plus 3 equals 0. And it tells us our critical values, because we're solving this equal to 0, are x equals 6 or x equals negative 3. And that comes from here. This is that gives us a negative 3. This one gives us the 6. And so our 0 values, f of 6 equals 0 and f of negative 3 equals 0. These are our critical values. If I put in 6 or put in negative 3, I get 0. So if I look on my graph, my points are at negative 3 and positive 6. My graph is going to look like this. Now I could work out all the values in between, but I know for a fact that the value here is going to be less than 0. And I know that a value out here is going to be more than 0, because the quadratic is positive up here. Maybe the graph went the other way around, but you know what? If I wanted to check, if I think about my grid, my negative 3 is going to be up here. If my x values and y values, my negative 3 is going to be here, and my positive 6 is going to be down here. That's also f of x, we can think of that as. So I could try out 0. Let's see what happens with 0. And if I plug 0 in, I get 0 squared minus 3 times 0 minus 18. And that gives me 0. Oh, sorry, it gives me negative 18, because obviously it gives me 0, 0, and negative 18, which is less than 0. So let's go back to this original equation. We know our original inequality. We know our critical values are negative 3 and 6. And we know that it goes less than 0. When x equals 0, we get f of x is less than 0. Therefore, it must be outside. We're looking at our answers must be values bigger than 6 and less than negative 3. Because if we look at this graph here, answers bigger than 6, like here, let's say 7 or 8 or 9, answers bigger than this value of 6 are going to give us answers which are bigger than 0. Give us results that are bigger than 0. And things less than negative 3, so that's negative 4 or negative 4.5, those are all also going to give us values bigger than 0. It's only the ones between that are going to give us less. And as we want values bigger than 0, our answer is our x's need to be less than negative 3, or our x values must be greater than 6. And those are the only possibilities. So this is your process. Find critical values by solving the equation f of x equal to 0. And then afterwards you need to decide inside or outside. Okay, so let's look at this final one. Solve the inequality x squared plus 11x minus 2 is less than 0. This won't factorize, so then we want to go to our quadratic formula. So we want to solve for our critical values. We're still solving x squared plus 11x minus 2 equals 0, but we want we're going to have to want but what we need to do is use the quadratic formula to get these answers. So we get x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And we remember our values. If a is going to be 1, our value of b is going to be equal to 11, and our value of c is going to be equal to negative 2. And so we get x equals negative 11 plus or minus the square root of 11 squared minus 4 times by 1 times by negative 2. And that's going to be all over 2 lots of 1. And we can work that out. We get negative 11 plus or minus the square root of 121 minus minus 2 is plus 8 all over 2. So these are our critical values. And we're looking for, and at this point you can just use a calculator. You need to find out your two options, negative 11 plus the square root of 129 over 2, and negative 11 minus the square root of 129 over 2 are our two values that we have to work out. Again, using a calculator at this point if you want to find the decimal. You don't actually need to find the decimal. We can obviously identify that this is the bigger one and this is the smaller one. So you don't need to use a decimal, you don't need to use a calculator to find a decimal at all. So what we can do is now just ask ourselves, is it going to be between them or outside of them? Well, if I use my graph, it's a positive quadratic. It's going to look like this. And so if I want things less than 0, I want things to be less than 0, I need to pick all of these points here because these are the x values. Remember, this is our x-axis. These are our x values that go below the line, that drop the graph below the line. I pick an x value here and I go below the line. I pick an x value and I go below the line. So the ones I want are the ones between the 2 points. And so without even having to find the decimal, but again you can, I know that my x value has to be greater than the lower one here and less than the higher one here. And there you go. Those are your answers, and that is how you solve quadratic inequalities. Thank you very much for watching, and I'll see you in the next video.